Our next set of formulas are product to sum formulas. Just take a look, see how complicated these things are, but really they're not. If you look inside the brackets here, we've got the sine of u plus v and the sine of u minus v. Doesn't that look like the sum of two angles, like the sum formula that we've talked about before for sine, and this one just the difference formula? As a matter of fact, if you look over here on the right hand side, it says these things are really easy to prove if you just add and subtract the sum and difference formulas. And we're going to do that in just a little bit. You can see here I'd be adding those. This one, obviously, I'd be subtracting them, adding them for cosine, the difference plus the sum of them, and the cosine, I'd be subtracting the difference minus the sum. So look at these formulas so you can get a pretty good grasp of what's going on here. And it looks like these two things are just switched. And just by switching them, I'm switching it from a plus sign to a minus sign. Down on the last two, I have two cosines and it's plus, and two sines and it's a minus. And again, all of this comes from just adding and subtracting the sum and difference formulas. Okay, and we're going to do that in just a minute. First, let's talk about this. You might ask yourself, I know I did, like, why would you want to do this formula? I've got myself a product, and that product looks far, far simpler than this thing that's in brackets. I got half times the sine of blah plus the sine of blah. And the answer, well, there's a couple of answers. In calculus, taking the integral of a product is not quite as easy as taking the integral of a sum, because you can just break those two parts up as two separate integrals. That's one reason. The second reason has to do with logarithms and good old John Napier. So you remember that project that you did where you were John Napier? You're supposed to take a product of two numbers and then you turn it into the sum of two numbers using a logarithm. And that was the reason why they did that was because multiplying really, really large numbers was pretty time consuming. Before they had calculators, they couldn't just type that in. They had to do it all by hand. They had to also chisel it into stone, so that took a lot of time. So anyway, before there was a calculator, if you could speed up that process by doing some sort of math trick, that was pretty handy. So before logarithms came around, before Napier came around and destroyed everything, what people used were these product to sum formulas. Problem is that they were a lot more complicated than logarithms, so logarithms replaced those. So that's what this last part says, that before John Napier, some folks, some rather insane folks, used these product to sum formulas to do the same thing, to turn a product of two numbers into the sum of two numbers. And that had an absolutely impossible to say word that had to do with that. I'll go ahead and give you a second to try to pronounce it. No? Okay. Then we'll move on. Exercise 11, we're going to prove one of these product to sum formulas, the one for cosines. So if we look in the parentheses, this is just the difference formula for cosine. So I'm going to write it down. Cosine of u minus v is equal to, cosines go together, so cosine u, cosine v, and since this is a minus sign for cosine, we change it to plus, sine u sine v. Now do the same thing for the cosine, the sum of them. The cosine of u plus v is going to look exactly like this. The only thing that's different is going to be the sign in between them. Cosine u, cosine v minus sine u sine v. Now I'm going to add those two things together, and when I do, these things disappear. And I have cosine u minus v plus cosine u plus v equals two of these things because they're exactly the same. 2 cosine u cosine v, and now all I have to do is get rid of the 1/2 the 2 by multiplying by 1/2, and I'm done. Let me scribble this out. Okay, so now that looks like this, and I'm done.